will be a presentation here that is a video documentation system based on personalized ontology and social network. And I am launching Chen, and some of is my student, and one of my student, Henry Hong, will do the presentation here. So let's give a round for him to give us the presentation for the paper. Okay.
Thank you. Good morning, everybody. Today I will present our paper about video recommendation system based on personalized ontology and social network. We are from Choyang University of Technology. My name is Henry. And this is our outline. The first one is the introduction, and then our research methods and system development. We divide into building process and user similarity calculation, a rule generating algorithm to create the dynamic inference rule. And the next topic is our experimental results. We divide into the user's acceptance rate, normalization, and the calculation of the similarity, and the last is the conclusions. And this is our introduction. We try to create the ontology and record the user's interest in this, seeing a movie, and from the topic we try to combine with the social network, as we know that social network could have the information about our community, our interest. So we try to start to solve the cold start problem. The cold start is when the first time users using our app, there are no history about his interest or his seeing movie. So in the social network, we hope that they could solve this problem. And then we, after we get that information, we calculate the similarity between these users and his friends. And then we use the dynamically generated algorithm to choose the candidate for the users. We choose the similar interest with the users, and then we recommended the movie or video with GENA inference engine. And not only this step, but over the time, the ontology will accumulate personal information on web access, behavior, and habits. So we continuously update the ontologies so the accuracy could be increased. And this is our research methods and system development architecture. The users using the app that connected to the social networks such as Facebook, Twitter, or Google+. Then the system will ask for the privileged permission to access their data. So when the user give us the permission, we could crawl their friend list, and we could take their interest page, such as a movie page, like and comment and so on, and also their limited basics profiles. After that, we store the data, the information into the web servers, and we build up their personalized ontology. And with that, we will compare to their friends about their similar interests, and we calculate the similarity, and then with the GENA inference engine, we will get the recommendation list of the results. The first step is that we build the ontology. Our ontology is provided from two main classes. That are person and public movie class. And in this every public movie, we divide it into the genre as a subclass. So after the genre, we have the movie title that have been built with the information from the social networks. And we utilize the Protege software to create users' personal ontology model. When we install an app to mobile, the OWL can be dynamic applications. And this is the ontology step to get the recommendation list. So the personal ontology will be sent to the inference agent, and we get the dynamic rule 1, rule 2, and so on. And then after that we do the listeners system, and then we update the ontology into the newest ontology when the new information is being added. In the process, we do the 3 main calculation. The first one is normalization point. Normalization is we divide the acceptance rate of the users. Acceptance rate is the classification of the user's interest about the movie. We divide it into the genre. So when we have the we set the threshold is 0.5. So when the acceptance rate is more than normalization acceptance rate is more than threshold, so we will give the value is 1 and other is 0. After that, we calculate the similarity value with the XR operation between the normalization point users and the members. After that, we sort it to the similarity rank, so we could get the best or the most similar interest between the users. And this is our algorithm about the candidate decisions. When we get the similarity value is equal 0, it means that the user have the same similarity based on our calculation. So we will put its member into the first candidate list. And if similar equals to 1, so we put it in the second. So we have 3 groups of the candidate similarity list. After that, after we get the first, second, and third candidate list, so if we have the first one, we will use the first one. If the first one is the null or no have the same similar with the users, we will use the second. And if not, then we use the third. Note that if we use the second or third, the result would be worse than if we use the first one. And then we use the reasoners to create the rule, and after the rule we put it into the Jena inference engine, and we got the recommendation result. After that, we upgrade the ontology into the new one. And this is our rule template. So we utilize the RDF. So this is the template, and we have 3 rules according to the preference of the genre. Yes, this is the rules. And for the experimental results, we use we have the 4 steps. The first step is we collect the user's acceptance rate. And step 2, we normalize user's acceptance rate and calculate the similarity between this user and other users. And the last one is we get the result and show it into the mobile devices. And this is, we take the first 5 users we use as the sample. So in this graph, we could see that every users have the different preferences, and the most nearest users is that in the graph that have the most same point. So in this graph, we see that action is almost the best genre for this movie interest. And this is the graph that we use for the users that we use for the experimental, and we have 7 genre as our preferences. This table will be normalized, and we got the normalization of the acceptance rates. The value is 0 or 1. After that, we calculate the similarity and we sort it based on the best value. So we will compare the value of the users with all of the other users. So the smallest the value is the most similar the users with the comparison. And this is the screenshot of our application. So when the users start to use our application, the users will be recommend some movie even if they are the first time using our app. If even the app didn't have the history of these users. And to summarize our conclusion is that our study recommends movie for users combines the personalized ontology and the social network. We use the dynamic algorithm to adjustments by the user's habit, and we take the advantage of social network users and friends that could increase the interflow because they seen the same video. And in the future work, we need to collect more satisfaction of mobile users, and we need to find a classification functions to modify the way of we manually classify the genre. And we need to let more users to use our video recommendation app and try to modify our video recommendation app that can be more convenient for the users. Thank you for listening. This is our presentation. Thank you.
Any question? Due to this paper is my paper, so my question is very strange. Okay. So, but the first paper here, the first paper that was showing information in the relative network have also be here. Okay, then due to this paper is related use the information of the Facebook and to compare the interesting, but most important they use simple operation, the SO operation to reduce the computation time, not just calculate the similarity and to do some recommentation for the users. Okay, thank you for the Henry presentation. Thank you. And the next